What is up, ladies and gentlemen? Jesse Warden here. Today we are doing the Advent of Code Day 3, Challenge 1 and 2. I'm exhausted, so I don't even know if I'll be able to even complete Challenge 1, but we will try and see how far we get before I end it in exhaustion. So we're not going to have a 3-hour marathon tonight. I'm not going to last long. And we're not going to do Day 4 tomorrow, live stream. We might not have time. I've got some plans tomorrow night, so we might skip that. So I'll just do the code at some point in the future. So we'll resume on Day 5, which is going to be Thursday. So let's get down to challenge number 3 this evening. And I briefly looked at it this morning. I remember doing something similar to this last year, where you create a grid and you utilize the Manhattan distance to detect the distance between two things. And a lot of my coworkers today used Rust and Go and Ruby, and they used very non-brute force tactics, really smart ways of doing it. I'm going to do nothing but brute force, and I've already gone ahead and set up the canvas library for Elm. So if we want to have some way to visualize some of these points or wires, I gave up trying to find some old Flash code that had really cool wires that had like gravity. They looked, I don't know if you ever used Reason, the music making software, but if you turn it around, they actually had wires in the back that you could change your inputs, and it was just super cool looking. But anyway, so what we're going to do is try to attempt to do Day 3 in Elm here. If you're not familiar, Elm is a front-end language, very similar to Haskell. It's a functional language, statically typed, and has no side effects. And the goal is, if you compile it, most likely works. The problem with most likely working is that there's no guarantee your logic is correct. And you've handled maybes correctly and everything else. So we're going to attempt to do that. So we're going to find the intersection point closest to the port, blah, blah, blah. Let's get our puzzle input first and start parsing this stuff. So I'm a little weirded out. Why does it have this weird thing here? So you need to find the intersection point closest to the central port. All right, let's share this URL here and put it on social media, and then we will attempt to figure out what in the heck they want us to do. Live streaming now, the Advent of Code 2019 Day 3 challenges. See how this goes up in this mug up in here. On LinkedIn, we're going to be professional tonight and drink water instead of alcohol on a weekday. Oh, I like being professional. Now, if I was looking for a job, I would wear a suit. I would drink a protein shake. But since I have a job, I can get away with being a little schleppy. All right, let's read this input before we try to parse it, and we will attempt to see how we can get on with drawing these wires here. Because the wires are on a grid, we need to use the Manhattan distance for this measurement, where the wires do technically cross right at the central port where they start. The point does not count. So we cannot count the point where it starts, and if a wire passes itself, we need to look up, does a wire occupy that space, and if so, it doesn't count, which means we need to have a lookup table to identify points, which is going to make this code really slow the way I write things, but that's okay. One of the wires technically cross right. For example, the first path is R, then starting from the central point, it goes to the right, then up and down. Okay, so we're going to draw some paths here. The second wire's path goes up 3. Its port is 3.6. Okay. All right, so first things first, let's go ahead and parse this puzzle input. And I don't like how it has this line break here. So I'm going to trim all the spaces somehow. I don't know. We'll figure it out. We will figure it out. All right, let's make sure this code is readable. And we'll paste our input there. And I'm going to manually clean this up now. I'm not going to clean this with parsing. I'm just going to go, ooh, why is it missing a comma? That's fascinating. Okay, I don't remember the input saying anything about missing that. So we're just going to go ahead and add a comma and fix the input. It's very strange. What if that's 2 wires? Maybe it's 2 wires. All right, let's reread the instructions. Maybe I missed something obvious to the rest of the world. Oh, okay, so the line break is the other wire. Okay. Fuel management computer styles, things for us. The front panel was a jumble of wires, specifically 2 wires are connected to the central port and extend outward from the grid. You trace the path of each wire takes as it leaves central port. Okay, the wires twist in term of the end pass. Okay, so you got to get 2 wires. No big deal. Okay, I'm excited. I thought it was like 50,000 wires. I'm getting a lot less nervous. All right, so let's undo that. We got our line break. Good to go. Wires twist and turn, but the 2 wires can cross paths. Need to go because the wires in a grid. Manhattan distance. Okay, let's do this. Let's find a way to do a line break. I know how to do split, but I'm not sure. You know what I could do? Let's do this. I don't know how to do a line break in the REPL. Does that even work? I've never attempted a line break in the REPL before. Let's say A equals 1, 2, 3, blah blah blah. Enter. Yeah, can't do it. Yeah, it is missing. Am I allowed to do like this maybe? Like in Bash? Fantastic. Okay. Perfect. Okay, so then I could say like string split on a new line character and then A. Cool, and it gets 2. Okay, that's fantastic. Is there a trim in string? If there is, then we can clean this guy up. Clean this guy up. Are you saying he dirty? He dirty. All this Elm code. It's compiling. Trying to catch this string. Looking dirty. Where is my string? Trim. Oh, it's a package dodge. All right. Core string. Is there a trim in here somewhere? Good. Okay. So we can trim out the white space after that. Fantastic. So let's go ahead and set up our parse puzzle input. We'll go to our update. We can get out of this REPL here. We don't need this anymore. We can actually get rid of this because it's always going to compile because I'm feeling good, despite the fact I'm exhausted. Long day. Had to deal with some really nasty Go code. I actually hate the code base. But I do my best. I got a good team, so that helps. Always good to surround yourself with people who are better than you and have good attitudes. They bring you up. So if we're loading our input, we need to parse it. So let's go ahead and what are we going to do here? We're going to do wires. Wires have instructions, and they are just a list of instructions, and each one of those instructions is a direction. So hold on, let's think about the type here. So it's a right, up, down, left, or right. Okay, so let's go ahead and make a type for that. A type, an enum type, right? Because we only have known direct. We're going to assume that we never have parse failures, which is always good to assume you never have failures because that always works out well in programming. I'm being sarcastic. So we'll say up, right, down, and left. Such as north, east, south, and west, or never eat soggy Wheaties. Same thing. All right, so that's the direction. And then we need to know the points. Now, some of these points are gigantic. Look at this. 991. I mean, this is crazy big here. Let's go ahead and extend our canvas real quick before I forget. What is my canvas width? Let's make some constants here. We're going to say canvas width is 400 and canvas height is 400. So we hard-coded it to that, but I'm thinking we're going to have to do, let's do 1200 so we have some, well, we'll do 1100. We'll do 1100 so we have a buffer for some of these gigantic things. And so we'll replace the hard-coded values here with the canvas width and height. And then we will go back to our, yes, it's a lot bigger now. That's pretty big. Let's, we're going to need a bigger browser. Let's make this 1224. Does that give us enough buffer? Good. All right, that gives us enough buffer. So we have enough room to draw here, which is good. And the height actually needs to be probably 1400. I mean, it's got some stuff at the top there. We could also, I don't know, we might be able to shrink it down, but we'll leave it at that. I don't know what this black stuff is at the bottom. That looks fantastic. And I wonder if I take out the border. Like if I just take out the border and just draw a clear, do I even need the border? Yeah, I don't need the border. That was a stupid border that I attempted to draw and I failed at life. Fantastic. We don't need a border. I'm a new age coder. I don't believe in borders. Unlike Trump supporters. Ha. Okay, I'm kidding, Mom. I'm kidding. All my conservative friends. I'm sorry. All right. So if we parse the inputs, we get an amount. So it's not just direction, but it is a draw instruction. So we're going to say type alias draw instruction. And a draw instruction is an alias which has a couple properties here. The first is it has a direction, which is a direction type, and it has a distance, which is a pixel amount. So I believe it's just an integer. And that means we count that many pixels from where we draw it. Okay. And using those two things we can know, but we also need to know where is it starting? What is the X and Y? So we need some kind of point here. So we'll create a type alias of point. And for now, our points are going to be integer based, but we might have to convert them to floats to draw. So we'll just leave everything in ints for now, since it makes the array and list math a lot simpler. So let's say X is an int and Y is an int. And what else? Now that we have a draw instruction, we know where is the starting point of this draw instruction. So it has a point that it starts at. And we'll do this in proper Elm style here, since I don't have the formatter installed. Make it nice and cuddled. Cuddle them dim brackets, yo. Okay. That's good. So that allows us to parse a bunch of draw instructions out based on a point that it starts at, and the default point is unknown. So we're going to say an unknown point, or a default point is a point that's off screen. So we'll just say -1, -1, because we don't know where that is and it's unknown, right? So that's a default point. And that way we can have a default. And so our initial model is going to get an array of wires. So we're going to say wires here, which are a list, or is it an array? It might be best as an array because we need to get particular indexes. Let me verify if there's a way. I can't remember if there's a way to map and list. There might be a way to map. Is there an index in here? Yeah. So we could use a list. List of we'll go to arrays if we have to. So let's start with a list. A list of wires. And a wire is a list of, I would say, draw instructions, right? And it has some kind of, I don't know, I guess ID or index or something. I guess for now we'll just use the type as the definition. I don't know if we need to reference them yet. So we'll just say for now wires are a list of wire, and wires currently contains a list of draw instructions. So we have two separate wires, each with their own draw instructions. The draw instructions are enough to identify what makes it up, where does it actually start, what direction it goes from, what is the x and y coordinate that they actually occupy, and then x and y coordinate, although they're ints, that can correspond to a tuple, or it could correspond to a float. This is a drawing instruction on the canvas. So I think that should be good from the parsing perspective. So now that we have our types, let's go ahead and parse this up. So we'll set our initial model to wires, which is an empty list. And when we parse this, we're going to have to do a couple things. So we're going to say the wires, because that's what this parse function is going to do. And it's first going to get the model input. We want to do a string.split on the new line character. That will give us the initial input. So let's go ahead and log that out. Where's my log? Let's verify we can read the wires here. Message 1. Wires. Wires.com. Go to the console. Load the input, parse the input. Okay, so our parsed input, and let's fix this real quick. Load input. This is supposed to be number 1, and this is supposed to be number 2. Much better. Okay. So it looks like it's doing pretty good. I'm struggling to identify the second string in here, however. I don't see 2 arrays. Let's make sure I didn't break my puzzle input. I don't think I did. Yeah, it respects the line break here. Huh. Let's go to puzzle input. And we get our initial puzzle input, and we split it on the new line character, but it doesn't seem to do, I don't know. Let's do this. What is list.length? Is it count or length? I think it's length. Let's give length a shot. Okay, so it is in there. I can't see it because I'm blind. All right, so we got our wires. We now need to parse each one. So we're going to go ahead and get each one of those set of string instructions to a set of wires. So we're going to say list map parse wire from, yeah, just parse wire. I mean, it's a string, right? So we'll go to parse wire. And what parse wire is going to do is take in a list of strings and do stuff. I'm not exactly sure what. Let me log this out one more time just to see what the array structure is that we're dealing with, so I can parse this. Okay, so it's currently a single string. That's okay. What we want to do is split this on the chameleon. And I don't know what the return type is yet, so I'm not going to put it because I don't know what it's supposed to be. All right, so that'll give us an array within the array of the strings, which is fantastic. And I don't think we need to trim it, so I think we're okay. I think we're okay. Good. Now let's do the parser. I forget, there's a couple options I could do. I'm just going to see if I can keep the parsing super simple for right now because our data is actually pretty good quality. Is there a way to get a character from the left? Okay, so we could take the left character 1. Okay. Cool. So let's, now that we have a list of strings, let's do a list map, and then each one we're going to convert to a draw instruction up here. And the way we do that is we identify what is our parse draw instruction. Did I spell that right? From that particular string, we need to get the first character. So let's go ahead and get the first character. The first character is, and it's not a maybe, right? Fantastic. All right, so we're going to say string.left 1 from the string. And from that, we have to parse a direction. So we'll say parsed direction. And from a string, actually, this is a car, single car. Let's parse this direction. We'll basically say case of car. And I'm not sure how to verify we've covered all angles, but we'll assume we did. So say case car of, if it is a, what's the data look like again? RULD. Okay. We can handle this. If it's an R, then it is right. If it is a, let's start with U, just to start from the top. If it's a U, we're going up. If it's an R, we're going right. If it's a D, we're going down. If it's a L, we're going left. So this will get us our direction here. And our parse direction from the first car gives us a direction. The other numbers are basically the string to the right. So let's verify that this math is correct here. I'm going to open the REPL and do some string math. So if we have, let's say, an instruction that is R338, or let's say 342, and we want to do the string dot right, which I think is the string length A minus 1. Yeah, okay, so that'll give us the length subtracted from the first character versus 0, which would give us the whole thing. Okay, so we can take this algorithm, exit out of the REPL there, and utilizing this algorithm, we can get the string length, I guess, or not string length. What is the type I made up for the initial draw instruction? The distance, string distance. We'll actually say distance string to make it a little more accurate as to what it is. So based on string right of the length of the string, that'll give us the numbers, and then we can parse those numbers, which is distance from, I think it's from, is it from to int? I forget if it's to int. To int. Right, string to int. Okay. String to int is going to give us, sadly, a maybe. And maybes are the worst. Distance string. So we're going to take this distance string. Yo. Yes, ma'am. Distance string. We're not going to deal with maybes. So we're just going to say with default, if we can't parse it for whatever whack reason, it's going to default to 0 distance. And then from that, we can get ourselves a draw instruction. So based on getting the string, we'll get a draw instruction back. Our draw instruction has 3 parameters, if I recall: direction, distance, and starting point, which is direction, distance, and we'll say default point, which is the -1 because we don't know where it is. So this will give us our default draw instruction back. And why is it mad about the first car? Oh. Well, I don't know, man. If you say if you say string left, does that actually give you? Yeah, it gives you a string. So actually, we don't even need a car. Okay. We'll just change it to a string. My bad. It says car, but whatever. We'll say you, soldier boy. That'll give us our car. All right, why is she mad? This case does not have branches for all capabilities. All right, so which means we have to handle a maybe. All right, so if we don't understand it, we'll just say up for now. This is horrible, and we'll have to fix this. Okay, that gives a parse instruction, and then from a draw instruction, we should be able to log that out and take a peek into what our parser is giving us. Cool. So we parse it. We get a direction. We get a distance, a starting point as to where it goes. Fantastic. Okay. And each one of these is an array of draw instructions. So fantastic. Where do I start? All right, so where is the central port? Trace the path of each wire at least central port, one wire per line of text input. The wires twist in turn, but the wires occasionally cross paths. Fix the certain events because the wires are off on a grid. Use the Manhattan distance. This measurement, wires are technically cross right at the central port. The point does not count. For example, wires path starting from the central port is right 8. That is fine, but I don't know where my central port is. Like, how do I know where my central port is? It's not clear. Specifically, two wires connected to the central port. Extend outward to grid. You trace the path each wire takes that leaves the central port. One wire per line of text. The wires twist and turn, but the two wires occasionally cross path. Defined because the wires on a grid. The Manhattan distance for this measurement, while the wires each technically cross right at the central port where they start. This does not count. Nor okay. Because right. I guess I'm confused as to where my central port is. This is bizarre. Interesting. Okay. Marked X, but the lower left one is closer. Here are a few more examples. R distance. What is Manhattan distance from the central port to the closest intersection? Okay, I am clearly confused about where the port is, so let's go find Advent of Code on Reddit and let's see, Advent of Code Day 3. And I'm trying to figure out where is the central port. That's fine, but where's the central port? All instructions are relative. Okay, so we can literally make our own central port. Okay, thank you, Reddit. So let's start with a central port of some location. So we'll put that in our model. Starting port, which will be some point of, I'm going to say, let's do 10 and 10. Start from the top here, which it may go around. So actually, you know what? We should probably divide that. Let's say 500, 500. So we'll start directly in the middle and see what happens to where she goes. And you know what's interesting about that is that means that the canvas is actually going to be so huge that it'll draw off. Okay. I wonder if there's a way to divide the size of the canvas. Let's see if we can do this. HTML canvas divide by 2 or shrink or halve. There's got to be a way to shrink it down so I don't have to, or scale it down. I'm sorry. Yeah, canvas scale, canvas scale. All right, hold on. Maybe he has it here. Scale. Nope. How about settings? Scale. Nope. How about advanced? Okay. If we do a transform, oh, that's to the matrix. Wow. Okay. Canvas. Scale, bruh. Is there not a way to do this? As a style? Okay. So we'll do, where's the style here? So if I say scale with 50%, does that work? Let's see here. And we'll fix our starting point, which is 500 by 500. Our model needs to have the starting point defined as a point, which is fine. And cool. Okay. So we could even do it like 20%. Let's go find 50% and see if we can scale it to 20. And does that even work? No, it doesn't seem to. Interesting. How are you doing it, Ellie? Are you scaling it? Where are you putting your styles? Oh, you're doing the style in the canvas. Okay. Style border. All right, let's do this the hard way. So they have a width and a height. Is there no scale? Interesting. So it's actually an attribute of the canvas. It's not a style. Okay. That's actually drawing the scale width. Is there a CSS scale for canvas? I need. What is he doing from the scale? Yeah, he's redrawing it. Okay. Let's set the width to like 400. See what that does. No, that doesn't. I don't know. We'll figure it out later. I'll see if I can scale it down. For now, we're just gonna have to go super big, which means I will zoom out and cheat. All right, so that'll make it a really big canvas, which gives us plenty of room. So we're going to draw from the middle, and our starting point is going to be 500, 500 in the middle. Let's go ahead and parse the wires, which we've successfully done. They start there, and then we'll start drawing once we parse the wires. So the wires are getting us a list of draw instructions, and each map is I believe, a list length 2. Each list of wire instructions, we can say list.map parse wire. Parse wire is expected to take a list of draw instructions and return a wire, which should be a really simple parse. It should just take that list and say wire list for now. And that should be good enough, right? Okay. From draw instruction list. There we go. Okay. So I'm expecting a list. The argument is a list of draw instructions. I do not need a list. What's the wire? Is draw instructions. A list of draw instructions. So I give it a list of draw instructions. Interesting. So this correctly gives me a map which has a list. Oh, because it's deeply nested. That makes sense. Yeah. Okay. I understand. What happens is when you write this out, you're actually getting the deeply nested list because the first one doesn't do it. Where is yeah, it gives you a list and then another list. Okay. So we need to find a way to take that out. Map will give you a draw instruction and okay. One nice thing about functional programming is you can comment out lines of parsers to see what happens. All right, so you get your first list and then your second list. So I think that's getting a list of draw instructions, and then you map each one, which gets a list of draw instructions. What if I did list, did that? Does that fix it? Yeah, but it's still missing a parameter. Let's do this. Let's give it a list and figure out what's going on here. So we'll do let log the list because I'm unclear exactly what list is here. All right, so each list, is actually, it's looping on the draw instructions. All right, that's no bueno. We do not want to do that. That's fine. Let's take a look at this beast of an item. Let's do list of head and see what the first item is. Okay, that's fine. And then do list tail. Get the end, aka the second item. So it's getting two completely different lists. Left of 997 And the first one is not a left, it's a right. Yeah, so it's getting both, which is fantastic. It's getting two arrays. I'm curious. Item. What are you, item? I'm going to return item back, so it's just going to give it back. So I find it interesting that it takes a list, and then of that list, it goes through. Let's say we get list of draw instructions. And then we'll tab these over and return the list of draw instructions. And to beat a dead horse here, verify we get 2, which we do. Okay, so each one of those should be a wire. So I'm confused why, if we do a list.map on this guy, we return the wires, let message 2. Yeah, I'm confused. Why is it looping through each one? Why doesn't it get the list? That's super whack. Super whack, man. I must be missing something super fundamental. This is what I get when I code when I'm tired. Okay, so I have a list of 2 things, but how come when I loop through the 2 things, it maps 50 times? What am I missing? Probably because I parsed the draw instructions. That could be it. No. It's still 2 even if you do this, right? Yeah. Still 2. Okay. Ugh. All right, let's see here. Oh my goodness. I'm stupid. It's a maybe. I missed the just. I completely did not see the just. Okay. So string.split gives you, which is fine, but one of these guys gives you a maybe. That's hilarious. All right, I completely missed that. How did I miss that? Man, oh man. All right, so assuming we just log this out. String.split will give you all right. I totally forgot. I need to sleep. Ugh. so that gives you a string. So where is the maybe coming from? What am I missing about a maybe here? Oh, the head. That's what it is. Okay, that's fine. So it is giving me the list of instructions. And then if I continue parsing the draw instructions on each one of those guys, then it should give me a nice little array of everything. Yeah, single array, right, of just that one. So that's fantastic. That's good. So why is it when I map again through both of those arrays, that, I don't know, let's see if we can find the second one there. There it is. Right there. So we got two arrays, which is good. And it's going to send that array of arrays to this guy. Whew, I'm tired. Message 2. Log the item. Never give up. Print out this. All right, well, it's taking the result of that. It should be two lists, not a single list. Parse list of draw instructions. Let's play around here. Let's just see what happens when I do this. Right. Argument is a list of draw instructions. Okay. Oh, my bad. The argument is a list, but it is piping it to something needs a list of strings. Well, it's because you already parsed it, you dum-dum. Let's do this. The argument is a list, which is a list of strings. Okay, that's the disconnect here. Is that not right? The argument is a list of strings. Okay. List.map parse instruction based on that string. Yeah. List of strings, blah, blah, blah. And then, okay. So we got a list of strings, return that back, and then list of, let's say, draw instructions, and return a wire that has draw instructions. So we're literally just mapping that array back, and she gives two wires. Drawn, yeah. And then if we count the length of the list, it should be 2. Cool. Okay. So let's, for now, don't need this guy. We're just going to keep our original direction here. Do I parse draw instruction? I do. Okay. And we can get rid of this. So now that we have our parse, we don't even need a parse wire because it is right there. All right, so we parsed our wires successfully. Let's go ahead and draw them. We'll go to the view and we need to loop through. So we'll clear screen and then we'll do view wires. We'll pass in the model, just the whole model, because I think I need everything. And here, let's separate this. I don't know why this isn't separated. So view wires, taking a model, and it's going to do a list dot, I guess, map on like canvas instructions, and return a list back. Yeah, that sounds about right. So model dot let's do a view wire because I'm not really sure. View wire. Wires. View wire. So view wire is going to take in a wire and expected to return canvas instructions from that wire, but I need to know a few things. I need to know the initial, I need the starting port. Okay, wires. So we're going to say starting point, and we'll leverage the function partial for that. So we'll say starting point, which is, I believe, the model starting point. And then, cool. Using that wire, he can loop through the wire dot draw instructions. And each one of those can get us a point that we can add. And let's see how this works. We're going to get a draw instruction. So we'll say draw, view draw instruction. And from view draw instruction, it'll take a draw instruction, and we can use this to identify where the pixels should go. So let's take a look at canvas here. And I'm looking for specifically to line, or is it line 2? I think it's line 2. Okay, so we need shapes. So do shapes, and we don't have any styles for it. We need a path. What is path? I don't know what path is. Path segment is mandatory. Path starting point for the path. Okay. Select line 2 connects last point for shape straight. Okay, that's fine. What is the two parameters? The path point that it starts at and a list of segments. Cool. Okay, that I can do. So the starting point is part of this. So we'll do this too. We'll pass this down. Starting point. And the starting point, I believe, is actually the draw instructions. No, it's they all use the same starting point. Okay. So his starting point is also a function partial. And so starting point x, starting point y, and then from that tuple, we need to provide a list of line 2's. Okay, I can do this. So these line 2's are list.map okay. I don't know if we need draw instruction, but we do because we have to draw a particular one. We need this part right here. We need the the actual drawing part to be in the path. So let's figure that out. I'm just going to give it a shape back. That's what I'm going to do. Right? Because, like, here's the thing. You know what it could do? It could literally just return a list of line twos, like line two instructions. You know what I'm saying? So let's think about this. I'm going to give you a draw instruction. And from that, I need you to do some stuff. What do I need you to do? I need you to give me this stuff down below. Basically, right here, I need a bunch of line twos. So it's that plus whatever you give me. What you give me is a draw instruction, which will become a line two of draw instruction, which I can destructure actually. Let's get a type just in case. Distance, direction, point. Okay. Let's copy this here for a minute. So to convert this to a point, I need to use the draw instruction to go each time. So I'm actually looping through it. So it's not an index map, it's actually an indexed map because the first one will move the points over. Okay. And each drawing point will have a set of instructions which need to map to the line to. Okay. I think I have 12 minutes left before I pass out in exhaustion. All right, so we're going to start with the starting point. Okay, I got an idea. Let's do get line twos from draw instruction. I need to know where to start. I need the draw instruction. You give me those two things, and I can do a list dot map on the draw instruction direction and distance. So I can do a range based on a direction. So if the direction is up, I can do a range of tuples. If it's a range to the left, I can do tuples, so I can keep drawing based on the direction. Okay, I can do this. All right, I'm gonna go pass out. I'm definitely gonna complete this tomorrow. I just need to get the map to do the tuples. All right, cutting it short tonight, ladies and gentlemen. I'll see you Thursday. We'll continue this, and then we'll see if we can catch up.